All right, last thing I want to go over for this particular section of factoring trinomials, although some of these will just be binomials. Of course, before I do that, I just want to tell you a thought that I had. If Snoop Dogg was to die before marijuana was legalized, would he be rolling in his grave? Hey-o. All right, so today's thing is factoring special polynomials. Okay, isn't that special? What I wanted to remind you of what the special polynomials were when we did multiplication. So it looked like this. We had x minus 3 times x plus 3. Right? When the two terms in both polynomials is exactly the same and the sign was the opposite, you squared the first term and subtracted the square of the second term. Right? Multiplying special products. This is factoring special products. So instead, you're going to start with this term and know how to quickly put it back into that form. That's what we're going to do today. Okay? And then the other special product was when you had the term squared. Recall, please. You squared the first term, multiplied the two terms together, x times 8 is 8x, and doubled it, 16x, and then squared the second term. Right? These are the two special product situations we just tested on. So of course now what we're going to do today is starting with this and quickly jumping back to that. Okay? It's how to recognize that you have that to jump out at you to make your life so much easier and quicker. Recognizing special products helps you move through these problems very, very easily. Okay? So again, the two special product situations, the same terms with different signs, or the one term squared. Those are the two things to look at. We're going to work them in reverse. All right, so I am going to be on page 401. I'm going to put the eraser, there it is. Slide over and look at the first sections. 4, 6, and 8. The very quick way to recognize that you have this special situation is, really what I want you to recognize most of the time is, are both terms perfect squares? If you can recognize both numbers as perfect squares, you know you're good to go. So I've looked at number 4. I've got the number 1 in front, which is a perfect square, and 81, which is a perfect square of? Megan?
9.
9, right? So I've got two perfect squares, so I write my two brackets. I know one's plus, one's minus. It's z plus 9 and z minus 9. All right, so you just square the first term, put it there with the variable, square root the second term, put it there, and then just change the signs. Each one sign different than the other. Okay? Number 6. You should quickly recognize 25 is a perfect square, as is 4. So, the square root of 25 is 5. The square root of 4 is 2 with the variable. And then just put one sign each, they're opposite. Okay? Down here, as you get more advanced with math, you'll start to pick up on perfect squares. 16 you should already know is a perfect square of 4. So 4x and 4x. 169 is the perfect square of, Megan?
13.
13 is correct with the variable. And you're done. Okay? That's all the harder this perfect square business needs to be. All right, we're skipping this next section. That's just trying to do quicker mental math, which I don't think is going to be of value to you. Let's look at the next section, 16 through 22. This is the other situation now, okay? Again, the principle is the same. Ignore the number in the middle. Here's what you need to see to recognize this is a special situation. First thing is, the second sign is a positive. That's the first thing you need to see. It has to be positive. Then the second thing is, Is the first number a perfect square? And is the last number a perfect square? If the answer is yes, you're in a special situation. So again, with number 16, the first number is a 1. It is a perfect square of 1. So we take the square root with the variable, it's just p. 225, Megan, is the perfect square of what?
15.
Good job using your phone. Okay, that is correct. The square root of 225 is 15. This sign is, everything's positive, so it's positive and squared. P plus 15 squared. Okay, 18. Perfect square, it's a positive. Square root of this is x. Square root of 4 is 2. I have a negative sign here now, so it's here, squared. 20. Perfect square. Square root of m squared is m. Square root of 144 is 12. The sign is positive. You're done. And 22. Perfect square. 7a. 1. This sign is negative. Put the square sign. And you're done. That is all the harder that needs to be right there. Okay? Just to show you, because this is going so quickly, we're almost done actually. Just to show you quickly, over here in this bottom section that you'll be doing. Oh, I do see one I want. Haha. Ooh, there's a couple of things. Great. So this says solve the equation. So sometimes you've got to do a little bit of manipulation. Manipulation. And I like it. So let's look at 28. I have 4x squared equals 49. Okay? And I want to solve it. Well, notice that not everything is on one side of the equal sign like you're used to doing when you do this. And it needs to be. Well, we can solve that. I can just subtract 49 from both sides. That leaves me with 4x squared minus 49 equals 0. And now it's where you've got it. And now what you should recognize is I've got a perfect square and a perfect square. I've got that lovely situation that looks like this. 2x minus 7, 2x plus 7. It's a special situation, equals 0. And then to finish, remember it asks you to solve. You need to actually give me an answer for the variables. So you set both of those equal to 0 like we've been doing, and you'll get x equals either 7/2 or negative 7/2, which you might also write as 3.5 and negative 3.5. So that's how you solve. Okay, number 30. Pretty straightforward looking problem in number 30. Everything's on one side of the equal sign, set equal to 0 like we like it. Again, perfect square here with the positive sign. It's a special equation that you can just quickly do this. Square root of this is s, square root of this is 10. It's a positive. Put your square sign, equal to 0. S plus 10 squared equals 0. You guys had a problem like this on your test, and most of you got this pretty easily. You don't got to set them both, just one of them. S plus 10 equals 0, so then S equals negative 10. The end. And again, if you want to check your answer, you can plug it back into the original equation and see if it arrives at what you want it to arrive at. Okay? (32). Y squared equals 12y minus 36. So again, what I would say to you is in these things we're working on, bring everything over to one side of the equal sign. Which way should you bring it? Well, you prefer to have your squared variable positive, so we're going to bring everything on this side over to the left by subtracting or adding depending. So when I do that, it looks like this. Y squared minus 12y plus 36 equals 0. So all I've done is I brought the 12y over by subtracting. I brought the 36 over by adding. Now I look here. I've got a perfect square and a perfect square and a plus sign in the second position. This is a special equation. I can quickly rewrite it as this. Square root of y squared is y. Square root of 36 is 6. Second sign is negative. There. Y minus 6 squared equals 0. And then just quickly solve. Y minus 6 equals 0. Y equals 6. I should stress your life with fractions. This fraction isn't that bad. Let's go ahead and do it. Might as well, right? So I have negative 4/3 x plus 4 over 9 equals negative x squared. And again, we want everything on one side of the equal sign, one way or the other. Hopefully you understand. We have a negative x squared, so clearly we want to bring that over to this side to make it positive by adding it. That will give us x squared minus 4/3 x plus 4/9 equals 0. Okay? A little hard. Need to write it better. Plus 4/9. All right. A little harder for you to see maybe at this stage. You know this is a perfect square. This is a fraction. But because the top number and the bottom number are both perfect squares, this fraction is a perfect square as well. So it looks like this. Square root of x squared is x. Square root of 4/9 is square root of 4 over square root of 9, 2/3. The sign is negative there and squared. X minus 2/3 squared equals 0. X then equals 2/3. Okay? Not too tough. Even though it had a fraction, even David, you can do it. All right. Last thing to look at, these bottom feeders. Factor the polynomial. So these involve doing just a little extra step. Okay? So let's look at 36. I have 2m squared minus 50. What is the common factor between 2 and 50? It's clearly 2. So if I factor out a 2 and rewrite, I have m squared minus 25. Once I do this, you should then see this is a special polynomial that I can factor very quickly. M minus 5, m plus 5. Again, because these are both perfect squares. Square root of m squared is m, square root of 25 is 5. It didn't ask you to solve it, it's just asking you to factor it. This is it factored. If you're solving, you'd set it equal to 0 and solve from there. That's not asking us to do that. Let's look at 38. 8k squared plus 80k plus 200. Okay? What is the term we should factor out? Now, be careful with this one. You could factor out an 8. That'll leave you with 8k squared plus 10k plus, if I did this right, let me double check it, 15. Is that right, Megan? Maybe that's not right. 8 goes in there, 240. Yeah, that's right. 8 times 15. Is that not? No. 2, 6, 4, 5. Yeah, it should. Oh, no. Oh, 25. Yeah. Sorry, you don't have to be careful. My math was wrong. Actually, that's what you should do right there. Okay? So when I factor out an 8, this is what happens when you don't do things ahead of time, right? You just figure it out as you go. I factor out an 8, that leaves me with k squared plus 10k plus 25. So now again, perfect square and perfect square. It's a special situation that I can then rewrite as 8 times k plus 5 squared. Okay? That's the factored form of 38. 8 times k plus 5 squared. And the very last one, I have 27m squared minus 36m plus 12. Greatest common factor. Megan, what's the greatest common factor there? Be careful.
Is it 3?
It is 3. Megan, good job. It is 3. So we factor out a 3. I'm going to write it up here a little higher. Is this in view here?
Yeah.
So factor out a 3. That leaves me with 9m squared minus 12m plus 4. Notice, perfect square, square root, square root. So I have 3 times 3m, negative sign, minus 2 squared. Okay? And that's your answer. That's it. Hopefully you see, as you do this more and more, this should become pretty second nature to you. Okay? But I'm going to tell you guys, in the online fashion you're operating right now, you need to practice. I don't have a lot of worksheets that I'm passing out to you. We're going to do work and I'm going to give you homework. You guys need to practice this so it becomes second nature. You're going to be doing this in geometry, I guarantee it, because I teach geometry. And you're going to be doing this in algebra too. Okay? And you may even do some of this in chemistry, I don't recall, and or physics. There's a good chance of that. Okay? Get comfortable with this. It's not challenging. It's kind of fun, actually, in my own twisted way. All right? So that kind of sums up factoring, trinomials, and special situations. See you tomorrow.